Hey everyone, I hope everyone is doing well. So I decided for Unit 12, we already did days 1 and 2. I decided to skip day 3, and we're gonna move on to day 4. So we're gonna start looking at log word problems. Okay, so if you look at day 4, right here it says step to solve exponential word problems when giving a formula. So basically for these questions, you're either gonna be using the formulas from day 1, or maybe day 2, half-life, double life, any of those formulas, or they're gonna give you a different formula that only pertains to that question. Okay, so there's a few different ways to solve these problems. So the first one is when you're strictly given Venn form, right? So if remember exponential equations, we have b raised to the exponent equals some number. So that's gonna come back into play. So now remember, if your b and your e are numbers, you just plug them straight into the calculator. If you need to solve and you don't have the exponent, if you remember, we go from Venn and we turn it into a log. So if you remember, we go log b n equals e. Okay, so remember, those are interchangeable. If you can't solve it in Venn form, turn it to log form and vice versa. If you can't solve it in log form, maybe turn it back to an exponential and see if that helps. Okay, so I'm gonna write that there for now, and I'm going to do a few of them for you. Now, there are a variety of different types of questions that we can do that involve log and exponential. So I'm going to try to show you the ones that are the most array of different types of questions. So I'm going to start by doing number 1. So it says scientists in the lab company raise amoebas to sell for schools to use in biology classes. They know that one amoeba divides into 2 amoebas every hour, and then they give you a formula. So right off the bat, there you go. There's the formula right here. Okay, so the formula says that t equals log base 2 of n. Now, when they give you a formula, they're always going to tell you what the letters are equal or to or what they represent. So here they tell us that t is in time. T is usually always time. This in case is in hours. And then n is the time it takes to produce a certain number of amoebas. So n is the number of amoebas. So part A wants to determine how many amoebas there would be after 8 hours. Okay, so 8 hours is time. So time is going to go in the t spot. So I have 8 equals, and then I have log base 2 of n. I'm solving for n. N is my number of amoebas. Now, if you remember from last unit, 2 units ago, right, we cannot solve this the way it's written. Right now we have log base 2 of n is equal to some number. So we're going to go up here, and instead of doing log b and e, we're going to change it to Venn form. So remember, log, here's my base, here's my number, and then here's my exponent. So when I change that to exponential form, it's now going to be my base, which is 2, raised to the e, exponent, which is 8, is equal to some number. And now when I look at that, I say, oh, that's easy. 2 to the 8, take my calculator, plug in 2 raised to the 8 power, I get 256. So the number of amoebas would be 256. Okay, so remember, if you can't solve it in log form, turn it into exponential. Now for part B, it says determine to the nearest tenth of an hour how long it takes to produce 10,000 amoebas when you start with 1. So there's my same formula again. So now it's telling me determine my time. So my t stays a t. And then I have log base 2. My number of amoebas is 10,000. So now here, log base 2 of 10,000, we can plug that in the calculator, right? The calculators that we have in the classroom, we just do math alpha math, pop that baby right in. We end up solving for t. Okay, so in my calculator, I just have to do it a little differently. So log 10,000, but you would just plug this straight in, log base 2 of 10,000. Log base 2. So nearest tenth, so you end up with 13.287. So therefore 13.3.
I totally understand. Yeah, no, I totally understand.
Okay.
Listen, I'm a city cop, so I'm not going to do
All right, so number 2, you are going to try on your own. Okay, if you kind of look at this formula, if you look at it, it looks a little bit fuzzy. So I'm just going to rewrite it for you. G equals I parentheses 3.1 raised to the 0.226 t. Okay, so that's that formula. Okay, so number 2, you're going to try. Let's see, 1, I want to do number 3 for you guys. Okay. So number 3, after an oven is turned on, its temperature is represented by the equation. And again, this one's kind of fuzzy also. So the equation is T equals 400 minus 350 times 3.2 raised to the negative 0. I can't even see what that exponent says. So we're going to just make it negative 0.2 m. There you go. That's going to be the formula we use. All right, so if we look, M represents the number of minutes after the oven is turned on. T represents the temperature of the oven. So how many minutes does it take for the oven's temperature to reach a minimum of 300 degrees? Okay, so that means 300 is going to go here in T. Now, here's where the equations can start to get a little tricky. So my negative 0.2 m. If you notice, my exponent is my variable, okay? And right now I have a whole bunch of numbers in front of it, okay? Okay. Now, this, sorry, my son was at my back door. This is the only number that is raised to this exponent. These other 2 you need to get rid of first, okay? The biggest mistake here is people take 400 minus 350 and change this to 50, and then they multiply these 2 together. Remember, this right here is the only thing attached to this variable right now, okay? You cannot touch anything in front of it. So if I think about this and I kind of want to work backwards and I want to get rid of these numbers, I notice these 2 are being multiplied, and this 400 I want to bring to the other side. So right now we have a plus 400. So if I want to get rid of it and bring it to the other side, I'm going to subtract it and bring it to the other side. Okay, so now we have 300 minus 400, which is negative 100 equals. So now we have negative 350 parentheses 3.2 negative 0.2 m. Again, you cannot multiply these 2 together. Only the 3.2 is raised to that variable exponent. So when 2 things are being multiplied and you want to get rid of them, right, or undo multiplication, you're going to divide out the negative 350. So you're going to divide out the negative 350. That is now gone from the right-hand side. Okay, so now I have negative 100 divided by negative 350, which is 0.2857 ... Now you want to be careful. You do not want to round your answer too soon. So that whole big number right there, this 28 number, 0.2857, we're going to leave it in our calculator that long. So now when I look at this, I say, okay, I finally got it where I only have one number as the base being raised to the exponent. But I can't solve it the way it is right now. It's in Ben form. There is no way to solve for the exponent until we turn it into a log. Okay? So if I think of this as Ben form, right? So if I go back up here, you have b raised to the e equals n. I need to change it to log base b of n is equal to the exponent. So right now my base is 3.2. My exponent is the negative 2.m, and my n is on the other side. So I need to change it to log base. My base is 3.2. Next comes the n, which is this really big decimal number. So 0.2857 ... And that is now equal to the exponent, which is the negative 0.2m. Running out of room a little bit. Now, the whole reason why we changed it was because these are now all numbers. We know in our calculator, if we do math, alpha math, that log base pops right in, and then we can plug that into the calculator. So for this, I'm going to do log of that really big number, and then log of 3.2 is my base. So when you plug this left-hand side in the calculator, you end up getting negative 1.077 dot, dot, dot. Now, normally our exponent is just a variable. This has a number attached to it. So when we plug this log into the calculator and get this decimal, and I set it equal to negative 0.2m, well, to get m by itself, I would divide by negative 0.2. So I divide that negative 1.077 number by negative 0.2. So I get how many minutes will it take my temperature? It says, does it say what to round to? How many minutes? Doesn't say what to round to, so we're gonna round to the nearest, doesn't matter, we'll do 10. So 5.4 minutes it'll take for your oven to become 300 degrees. Okay, so I know that one was that was totally new. That one always seems to be a little complicated. Okay, so let's see what other ones we have. 4, 5. Okay, so I'm gonna do another one for you. Let's do 4. Okay, Hudson invested $650 in an account paying an interest rate of 5% compounded continuously. Right there's my key word that we need to know from day one, that compounding continuously is the formula PERT. So A equals P times E to the RT. So he invested $650 into the account. That means that he put into it. Therefore, that is my P value. Remember, E is just the number, so it just stays in E. My interest rate's 5%. So again, remember, whenever you have a percent, you need to move your decimal 2 places to the left. So 0.05 is going to be my R. So I want to know how long it will take for the amount to reach 1,220, which means we're actually solving for the exponent. We're solving for time. So A is going to be 1220. And then my exponent is now going to be my R, which we said was 0.05. And then you're going to leave the T a T. We don't know how long it's going to take. That's what we're solving for. So just like we did in the one before it, we have an exponent that has a variable. We have our base right here, which is the E. The 650 is not the base. It is not the base of that exponent. So we need to get rid of it. In order to get rid of it, since it's being multiplied to the E, our first step is to divide it out and bring it to the other side. Okay, you should only have one thing as your base. So in this case, our base is just the E. You get rid of everything else to the other side. So I do 1220 divided by 650, and I get a decimal, 1.87 dot, 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 equals E to the 0.05 T. All right, we're up to Ben again. All right, here's my base, here's my exponent, here's my number. I cannot solve it in Ben form. I need to change to log B and E. So this is my base, here's my exponent, here's my number. So let's change it to log. So it becomes log base E of that 1.87 number equals your exponent, 0.05 T. Once you change it to log form, your left-hand side now becomes where we go math, alpha math. You go log base E of 1.87 number. So when I do it in here, let's say 1220 divided by 650. Okay, so log of the answer divided by log base E. Excuse me, I'm videoing right now. Sorry, that's my daughter. Okay, so you get 0.629. Okay. And then finally, sorry, I was distracted by my daughter for 1 sec. The last step is to divide by 0.05 to get your t by itself. So I divide by 0.05, so I end up with 12.59 dot dot dot. It tells me to round to the nearest year. So 12.59 would round to 13 years. Okay. I understand these ones are a lot more complicated than day 1 and day 2. Okay. So we are going to spend a little bit of time doing these because they are important. You need to just realize if you can't solve it in exponential form, you need to change it to log form. Okay? And you also need to realize that your base in all of these questions can only be one thing. It can either be a number, it could be an e. If there's anything else attached to it, you need to get rid of it first. Okay? All right, I hope this helped, and then I'll let you know which ones I want you to try on your own. Okay? Have a good rest of your day.